Today we're doing 4.1. Do you guys know what a cubed root is? What is a cubed root? So in a square root, we need two copies of something to build whatever's inside the root. So the square root of 16 is asking what times itself, or rather, what squared is 16? And in that case, the answer is 4. So if I had the cubed root of 8, that is asking what number to the third is 8? 2. 2 times 2 is 4 times 2 is 8. Now, there is something that is a little bit weird with cubed roots. If I had the square root of -9, that creates 3i. Because there is no number times itself, no real number times itself, that equals -9. So we've invented this other branch of numbers called imaginary numbers, and they involve i's. But with cubed roots, that doesn't actually happen. So this is saying what number to the third is -27. And there is a real number that satisfies that. What is it? -3. So why does a square root create i's, but a cubed root does not? Yeah. 3 negatives makes a negative. So negative times negative is positive, but if we bring in another negative, then that would turn that positive result into a negative result. So there are no i's with cubed roots. Okay, well, we can factor cubed roots and circle groups just like we do with square roots, but instead of looking for pairs, we're looking for triplets. So what goes into 216? I happen to know it's 6 times 36. Then we factor this, 2 times 3, 6 times 6, 2 times 3, 2 times 3. And when I circle groups, I'm looking for sets of 3. So we get rid of everything that factored. We only look at the numbers that are at the end of the list. So here is a triplet of 2's. And then here is a triplet of 3's. And don't forget the negative. So negative comes out. And all of the 2's came out in one group. And then all of the 3's came out in one group. So 2 times 3 is 6. So the answer is -6. Okay? So -6 times -6 times -6 is -216. All right, let's do another one. Okay. 64 is made up of 2 times 2 times 2 times 2 times 2 times 2. You could factor it out. Do I have any triplets? So I bring out a 2 and a 2, and nothing's left on the inside. So the answer is just 4. Okay. All right. Fractional exponents. In a fractional exponent, so this is the exponent and this is the root. So I need to rewrite 81 to the 1/4 as the 4th root of 81 to the 1st. So the denominator is the root and the numerator is the exponent. And in this case, I don't even need to write the exponent because it's a 1. But you'll see here in a minute that the other problems, you do need to put that exponent. So this is saying what number times itself times itself times itself is 81? 3. So if I factor this down, I would get 3 times 3 times 3 times 3. And I'm looking for a set of 4. Okay. This one is the third root of 125. And again, it's to the first. What times itself is 125? 5. Okay. Oops. If I had x squared equal 9, and I took the square root, don't forget that you have to put plus or minus 3. Whenever you square root an x squared, there are two possible answers. What number times itself is 9? 3 or negative 3. But in this problem, I have x to the third equals 1,000. So I take the third root. Do I need a plus or minus? No. The answer is just 3. What if I had the x to the fourth equaled 16? And I took the fourth root. Do I need a plus or minus? Yes. So just like 2's and 4's create i's, 3's and 5's don't. When you're taking the root of that variable to the power, even numbers create plus or minuses and odd numbers don't. So in this case, the answer is 10, not 3. But there's no plus or minus in third roots. Okay. So, a couple problems ago, we had something like this. And I said, this is the exponent, the numerator is the exponent, and the denominator is the root. So we could rewrite this as the third root of x squared. And this isn't totally true, but it's true enough for this class that we're not going to worry about it. That 2 can either go inside or it can go outside. It doesn't really matter. It's usually easier if you put it outside, but that's not always the case. So again, the 2 can either be there or it can be there. Now, there are some other rules in there that I'm kind of ignoring, but for the purposes of this class, it can be inside or it can be outside. So this question wants us to go backwards. How could I write that in exponential form? Well, the exponent is 2, so the numerator is 2. And the root is 3, so the denominator is 3. Uh-oh, she's on her phone. That hurt your grade. Don't be doing that. Does that make sense? Okay. Yeah, it doesn't want you to solve it. It just wants you to rewrite it. So let me look and see if they're going to do another one the other way around. Okay. So how would you convert this one to the other form? It would be the sixth root of a, and then the 1 either goes inside or outside, doesn't really matter. But because it's a 1, you don't need to write it. I wonder if Alex is going to freak out if you put it outside. I don't know. That's a good question. Okay, this will let us know. Oh, it does both. Okay, so We can write this as the 8th root of a to the third. However, it's more common to write the 8th root of a to the third. So they do allow for both versions. And again, there are some instances when those are not equal, but I think it will accept both. And it says it's more common to write it this way. That way is usually easier to solve, but it doesn't really matter. All right. Okay. What if the exponents are negative? What does a negative exponent do? Well, let's consider a to the 5th over a to the 3rd. Let's do it the other way around. A to the 3rd over a to the 5th. That is a times a over a. And then we just start canceling things. And on top, I'm left with a 1, and on bottom, I'm left with a squared. Well, if you're lazy like me, you're not going to write that out. How do you solve this without writing out all the a's? How do we turn this into that? We just subtract. And we say 5 minus 3 is 2. But what if we subtract it the other way? What if I did 3 minus 5? Then I would get a to the negative 2, and it turns out those are equivalent. It is possible to have a negative exponent, and it's just the reciprocal of a positive exponent. So a to the negative 2, let's look at it this way, a over 1 to the negative 2 is exactly equal to 1 over a squared. So negative exponents flip fractions upside down. So looking at this problem, I have 1 over 81 to the negative 3/4, and we do not want negative exponents in our answer. So I'm going to take this 1 over 81 and I'm going to flip it upside down and turn it into 81 over 1, which is just 81. And all that is going to change in the exponent is get rid of the negative. So the negative flipped the base upside down, and now I have 81 to the 3/4. When we convert that, we get the 4th root of 81 to the 3rd. Okay, and here's why I prefer to put the the exponent outside. 81 to the 3rd is a huge number, right? 81 times 81 times 81. So if you stick it out here, what is the 4th root of 81? 3. And what is 3 to the 3rd? 27. So that's why I prefer to put the root or the exponents on the outside. Now, what have we just done? Why is the answer 27? Well, if we look at 81 to the 3/4, this is asking, is there a number that you can multiply by itself 4 times and get 81? 3. So 81 is built of 3 times 3 times 3 times 3. How many of those 3's will be part of our answer? 3 of them. So 3/4 of the product of 81 is 27. Okay, so here I need to flip the 32 upside down, and I get 1 over 32, and we're going to raise that to the 3/5. Okay, well, 1 to any power is just 1. So it's really just 32 to the 3/5. And that's saying 1 over the 5th root of 32 to the 3rd. What is the 5th root of 32? 2. And then 2 to the 3rd is 8. So the answer is 1/8. What did we really accomplish? Well, we had 1 over 2 times 2 times 2 times 2 times 2. How many of those 2's are going to be part of the answer? Just 3 of them. So that's what fractional exponents do. Okay. Oh, we've done this one. You're just going to take the 3rd root. Oh, I see the difference. So v to the 3rd equals 28. We take the 3rd root. Do I need plus or minus? When do I need plus or minus? When the root is even. So I get v equals the 3rd root of 28. 28 is made up of 2 times 2 times 7. Can I bring anything out? No. What if this was 56? And I had 2 times 2 times 2 times 7. I can bring out one set of 2's. 2 times the 3rd root of 7. Okay? All right. Next up. Okay. Will A make an I? No. Only even roots create I's. So what number times itself is negative 27? Negative 3. Will B make an I? No. Why? The negative is on the outside, not the inside. So what times itself is 81? 3, and then the negative out front turns it into negative 3. Good job. Okay. So here, that would be the square root of negative 49 to the 1st. That is not a real number. It's an even root, and we have a negative on the inside. So it would be 7i, but it just wants you to hit the not a real number button. Okay, B, the 3rd root of negative 8 to the 1st. Negative 2. No i's there. All right, and then the last one. Okay, w plus 5 to the 3rd equals, nope, plus 54 equals 0. So if we look at w, 3 things happen to w in this problem. We add 5, we raise it to the 3rd, and then we add 54. So we need to undo those backwards. So we subtract 54, and then we take the cubed root, and then we subtract 5. So I get the cubed root of negative 54 minus 5. What is 54 made up of? 6 and 9, 2 and 3, 3 and 3. Can I bring anything out? set of 3's, and the negative, right? So we get negative 3 times the third root. What was left over? 2 subtract 5. So W is equal to negative 3 times the third root of 2 minus 5. Okay? All right. Get to work.